zoom this in so I can see it. Where's my zoom? All right, so we're starting here. I'm gonna read the problem off. Un momento, por favor.
Oh, you did, yeah.
Spanish is rusty. Running circles around me. So, the biggest thing is, how is your Greek letters understanding?
Pretty.
As far as your Greek letters, how many do you know?
I know a couple because I was part of sorority and.
You was in a sorority?
Yeah, it's not like a big name sorority, like like the Divine Nine.
Oh, okay. I'm like,
no, yeah.
Yeah, but you was in one.
I was in one. It's a Latino-based multicultural sorority. So I do know my Greek colors. So you said the U and this. I was like, oh, yep, the Omega. I was like, yep, I know that. So I remember studying about that. Yeah. So a little bit about me. I did that when I was going to school in Milwaukee. Yeah. I was in a sorority out there. So, I mean, I'm still a part of it. I just am not as active.
Yeah, a long time ago, before I did masonry, I almost became an alpha.
Oh, no way!
Alpha. They messed with me too much, and I was just like, I'm becoming better than what that is. And become your father. So I just became a Freemason. Because, the origins of that stuff comes from Freemasonry. So, but that's why I got started with the Greek letters plus engineering. Yeah. 90% engineering, you use Greek letters. That's why the kids flip out. That's why I'm talking to you about it.
Yeah, yes.
So you gotta get comfortable saying alpha and blah blah blah, and you'll hear me doing that. And I seen it recording. So put on my teacher hat for a second, and I'm gonna blast through it. If you got questions, stop me. So we're looking at the equation here on 274. Everything and this is how you would direct the students, everything in that box, I go see it every time, is going to cover everything I write for your starter notes. Okay. So, again, this is known as, you're going to have them, explain everything you're doing, and don't assume that they know. So, angular average, is what we're doing. Average, angular. And this is acceleration this time, whereas last week we were talking about, I think, the speed or velocity, right? Mm-hmm. And that's when we had omega involved. We go back to the CD player or CD example, you'll see that omega is involved here. And that's not W like I tell my students, that's omega, lowercase omega. Sometimes the uppercase omega is like the God of War symbol is turned around. Mm-hmm. That's omega as well, but I'm talking about lowercase. And then you see you're coming away from speed. Speed is also known as velocity. Okay. People get that confused. When you're talking about...
All right, have a good weekend.
Most times students get confused between speed or velocity when they look at the problem. Yeah. So that's how you're doing it, because speed is basically, it's the magnitude. You know about vectors, right?
Vectors?
Like how vectors are explained. So what's a vector?
Is that something with energy? Something dealing with energy?
You're making it too difficult already, so slow down. I'm going to give you the quick physicist answer. So you got a scalar and you have a vector. There's two different things, right? Mm-hmm. You know you have a vector because if I say, Garcia, I am going 65 miles per hour, which is that, a scalar or a vector?
That would be a scalar.
Right, scalar.
Scalar,
right.
Yeah. It's like
so now listen to what I say again. I'm going 65 miles per hour due north, which is that? Is that a scalar or a vector?
A vector.
So a vector, the simple answer, if anyone ever asks you, so you don't keep trying to think through it. A vector has magnitude and direction. Whereas a scalar only has magnitude. So you notice I said 65 miles per hour, but I didn't say direction. That's a scalar. So the same thing is true with speed in terms of velocity, right? So speed, if they say in just a value in miles per hour or something, that would be called speed. If they say you're going 65 miles per hour due east, then you know that's going to be velocity. Got it? All right, so that's why you have to explain vectors, because people, when they read through it, students especially, well, it didn't say velocity nowhere in the problem. It did. You didn't think about it correctly. Yeah, it did.
Gotcha.
Right.
Just having a little, add in a little.
Because you're going to have to help them break it down, yeah. The terminology is a mug, yeah.
So velocity is vector, what was scalar?
Scalar is just the magnitude. It's just a solid number, not positive, negative, not nothing, no direction. Just If I say I'm 100 pounds, right, but I don't tell you like which direction my pounds are going, anything, yeah, that's just a scalar.
Gotcha. Okay.
So, all right, so I hope that makes sense.
Yes.
But last week we're moving away from, like I said, omega into alpha now. So that looks like this, right? They have that symbol in their Google Docs, and it's an average. So they got to put AV. Well, AV is a subscript, and then you think about it, we're still kind of utilizing our velocity because now we're moving up to acceleration. And physics is like calculus because it's 2HT physics. You teach with algebra, you teach with calculus. Luckily, high school students only getting the physics version, and the derivative of this is the nerdy part of it, but the derivative of velocity when it scales up is actually acceleration. So it scales up. You start with position, and then the next step up, when you do calculus, is going to go to velocity, and the next step up is going to acceleration.
Gotcha.
So we have delta, another letter most kids don't like, right? Greek letter. And then you have that same omega.
Yes.
Whereas last time we were examining just that. So you see the equation is expanding
right.
as far as the concept. And then you still have to scale it over time, I think, right? Delta T. So these are delta is displacement, final minus initial, in case kids or somebody asks you that. And then of course you want to just break down what they're measured in, right?
Yes.
Again, when you're talking about omega, because kids get confused, you have two flavors. You have radians, and then you have degrees.
Okay.
Right? And that's important for robotics. It's important for cars. Anytime you're talking about rotation of wheels, you got to be careful which one you're using to measure.
Okay.
So radians is more about how many pi rads you're going in a circle, right? What I mean by that is, with degrees is very simple, right? You have 360 degrees, right?
Right.
So this is 0, 90, blah, 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 right?
Yes.
Radians, it takes cross sections.
Oh.
So it's more specific before you get to the end, right?
Oh.
So that's why I tell kids, that's why when I tell them to write the box, you want to write everything. There's a lot in there they don't explain. I think Miss Dennis saw that. She was like, yeah, it left out a lot.
Yeah.
I was like, yeah, I'm filling in the blanks for you.
Yeah, because
if you read that box, everything I'm talking about is not there. They're just going to tell you what the final SI unit is.
Right.
They're not going to tell you what all those are. They're going to assume you know it, like most physicists would, because you're supposed to know that. So this is usually measured in terms of radians or rads, so a short word for it, per second, right? Or you would say, for my people that drive cars, like myself, revolutions per minute, RPMs, that you see on your dashboard.
Yes.
That's why it's important. So. All right, time. Of course, that's always going to be in seconds when you're doing this calc. This is important things because as you pick the problem apart for your known unknowns, they can look at the kids look at the numbers and they don't know what the numbers are.
Yes.
And the problem is, you just got to look at what's at the end of the number because how physics determine where those numbers go, right? And then you have alpha. It's an acceleration. I don't know if you know that gravity is also a form of acceleration. And any acceleration is measured in terms of meters per second squared. Right? So it's m over s squared. Right? So usually you'll say meters per second squared when you're talking about this. But I'm going to change it because you notice we have rads per second. So we can't use meters, right? Because we're dealing with a circle.
Gotcha.
So that's why I said it don't show you everything. It says rads per second squared.
Gotcha.
Notice a change. So we're just going to change that a little bit. But normally, if you're just talking about mileage or running or without a wheel, you're going to use meters per second squared. So I don't want you to get confused.
Gotcha.
But since we're talking about a unit circle, right, we're going to say rads per second squared. And that's the SI unit. These are all SI units, by the way.
Oh, okay.
Okay, I think I covered everything. Now, time for our known unknowns. So we can knock this problem out. And you have to do a little bit of algebra, which I'm pretty sure you're capable of. That should be easy for you, the easiest part.
It's just this part, that's for,
You got to break this down for them. And this is going to show you mastery about what you're talking about.
Gotcha.
Okay, now, known unknowns, right? Let's knock this out. After this, I'm going to put on my coat and get the fuck out of here. I'm trying to get out of here. No,
I appreciate
this video is yours and yours alone.
Yeah, no worries.
Don't share with nobody but yourself. All right, so known and unknown. It's on Facebook Live. So one of my friends was like, "Oh, Tyler was tired or something," and I am. Hanging out with my friends too long last night. So what do we have? We look at the problem. And I want to see what you can identify. All right.
Okay,
So the problem's on the screen.
Okay,
Let's
so
give me zoom back out, or you need is that view fine?
I think that's good. I just probably have to do
So let's start with the first thing you can identify.
So far,
We're on
I
Wednesday.
see that's 3.48.
What's that though?
It's the acceleration. So it's angular acceleration.
So what do you call that, Darcy?
So that would be the.
Trying to get you to teach it. It'd be the. Say it again. It's not A.
It's omega.
Nope.
It's
Just write it for you. I just told you. You know your Greek letters. Come on now.
Yeah, I know.
So this is called alpha.
Alpha. Okay, yeah, that's what it was.
So angular acceleration, right? Is that what you got first?
Yeah.
You said it. You said the A
Yeah.
though.
Angular acceleration of 3.4 radians.
Or alpha.
Yeah, alpha. Okay.
Oh.
Okay. That makes sense. Yes.
Yeah.
Okay, so that.
You literally got to force them to use the Greek terminology.
Gotcha.
So that's alpha AV, or angular acceleration. Like see, it says it in the problem what it is, but they got to use this equation. So
Gotcha.
you got to get comfortable
Yes.
directing them towards
Okay.
the right verbiage. Okay.
Okay.
So you said it. We're gonna write it out.
So
So you got
is-
alpha AV, or angular acceleration, is equivalent to what? Let's see what you got up there. You
It's 3.4 radians.
3.4
So
radians.
we just put
You didn't say it
right?
right. You didn't say it right. 3.4 what?
3.4 radians per second squared.
Ah.
Yeah, because that's what that
Look at what's in the notes.
is,
Look
yeah.
at what. Yeah, it's right there.
Yeah.
Huh?
Yeah.
You said what?
I said, you don't know if we could leave.
I think
I
this.
think she said 1. Yeah.
Yeah, Miss O said 1 o'clock we can leave.
1 o'clock?
Yeah.
We gotta waste on 1.
Look at him. All right. Look here. Go ask Eris. I don't know.
Yeah,
Maybe she'll
yeah.
be lenient. I don't know.
Yeah, that's what she told us. Yeah.
After this, I know I'm trying to book too. So
Okay.
rads per sec squared, right? That's how you write that. So I'm waiting on you to tell me what else you got in your problem.
Okay,
So this is your journey.
So we got that portion squared, and then it's asking what is the angular speed of the wheels?
And what part of that?
So this would be the unknown, because that's what we're trying to
No.
figure out. No? Because,
I said, what is the angular speed? You're right.
oh, okay. So yeah, what is the angular speed?
But what is that,
So angular speed, that would be,
I want to see if you give me the right verbiage.
hold on.
Dun, dun, dun. We just covered this. We just talked about vectors and stuff. And the difference between speed and...
Oh. Yeah, because you just say wheels.
We just talked about it. So
Yeah,
what did I tell you about those vectors? I'm not going to tell you what the answer is.
Vector is where it's like one direction, and then
You guessing? Get your notes. Get your notes.
Okay, wait. Vector has a magnitude and direction.
Ah.
Like if you're going 15 miles north,
Right.
And then scalar is just magnitude.
Now go
So-
back to what I talked
Here.
about with speed and another word.
And wheels because they're rotating. I remember you said
Like that, but
rotating.
what's another word for speed? Starts with the letter V.
Acceleration? No, velocity. Velocity.
Lord help me, child. Okay, yes, velocity.
okay.
So what up here would be your velocity?
Our velocity would be.
You call
Oh.
it W. Why you say W? I almost throw this pen at you. W. What is the name of that Greek letter?
No, it's delta.
Nope.
No, next to delta, which is omega.
Okay, girl, I just told you earlier.
I know.
I gotta give my dad's military hand, like knife hand, like stop playing. So delta, omega, not W, right? Yeah, these Greek letters gonna kick your behind.
Oh yeah, this.
So just keep making note. This is delta, but this little thing right here, just make a sidebar, is omega.
Yep, I just said that right.
Yeah. Okay, get really comfortable with your Greek letters.
Okay.
Oh,
So
this
now
is all
that's-
engineers, and it's what now? It's 3.57, right?
Yeah, 3.57. So that's our
And
known.
just like velocity is measured in meters per second. Just like I was talking
Yes.
about acceleration is meters per second squared, but we're dealing in circles, so we gotta use rads per sec.
Just rads per sec, not per second, right?
Well, you could say seconds. It's just shorthand, but yeah.
Oh,
that's
I meant to
seconds.
say not the two, not the exponent.
Well, right, that's what I mean, not the power 2, because that's
Right.
acceleration.
Right.
Yeah.
Gotcha.
So you're saying rad
Sex.
per sec,
Yeah.
right,
Okay.
as opposed to seconds squared. And then your unknown, you told me, was what?
Is what is the angular speed? Right? Because that's.
Oh, so we didn't have. We got that mixed up. That goes here. You're right. Hold on. That's what that goes. Question mark.
I think that's the answer.
That's delta rads per sec. This is delta t, right?
Delta.
Because it's only seconds after that. Yep, that's delta
seconds
t.
after. Yes, it's after 3.5
There we
seconds.
go. Okay, you had to scroll up. I can see that. So now we're good. Unfortunately, this is when you're gonna use some algebra and pick this apart. So this is usually the hardest part for kids, besides the algebra. But if you can set this up, 90% of the battle is like accomplished.
Gotcha.
So let's box this off,
Okay.
right?
That's your unknown and known.
Mm-hmm.
And then, could you repeat it again? How did you figure out, or could you repeat it about, how do we know that that was the omega versus the t, which is,
So, because I looked at the end of the number.
oh, that's right, because you're matching it, that's what you did say.
You scroll up, okay, that's not correct.
Yeah,
Seconds.
gotcha, it's just
So you know
seconds.
seconds is measured by time.
It's by time. Oh, okay,
So
gotcha.
you said, what is angular speed? I was good.
Oh, that's right, because t is time.
That's omega. Yeah,
Yes.
T is, that's why it's best for you to write that out for students.
Yes.
Because then you get more buy-in from all the students. Because
Yes.
how did you know that? I looked at the end of the number. I didn't just see the number. I just looked at the end of it.
Oh, and you did say seconds is t. Yeah.
Yes. Yeah, right here. Yeah, that's why I break it down that way, because the book doesn't do that.
Yes.
Yes.
Okay.
All right.
Just
Now,
make sure we're good.
no, make sure you're good, because this is your show on that day. I'm going to sit back and be like, good luck. Good luck, nobody. Good luck. So let's do the algebra. I don't feel like doing it down there. My legs hurt, but you know, my feet all day. So I would say step one. It's really like one step. If you had two parts to it, it's two steps, but it's really one long step. You're gonna do the algebra and rearrange it. You're gonna solve for what? Well, you see our equation, the way it's set up. Delta omega, or our angular speed, is not by itself. So we gotta rearrange that equation a little bit using our algebra, right? So
Oh, because you don't have the omega there, right?
yeah, so you're unknowns. That's why I do this, yeah. So
Oh,
you figure out
it's
what
just
you
like-
gotta solve for.
Yeah, so it's just, yeah, so we have to,
Solve algebraically for
yeah,
our delta omega, or our angular speed, sometimes known as angular velocity, if you know the difference, right? They're kind of synonymous, but you gotta make sure you know that word means that, because that comes up as angular velocity, but it also can be codenamed as speed, you know. Anywho,
okay.
we're gonna rewrite the equation. Alpha AB, or average angular acceleration. And then that's equivalent to this. I'm just rewriting our tool, right? I usually write it once, and then I write it again and solve it, or work on it. Say put it on my surgery table, mathematical surgeon's table. That's a physicist. And now, it's like a one-step algebra problem, I think, right? So the goal is to get delta omega by itself. So
Right.
I want to remove this boy underneath, which is basically a division type process. So I can say, hey, multiply it by this quotient here. This is like basically saying, I don't really do this all the time because I just know that in my head, but sometimes I have to write that in because students be like, how you just multiply that? Well, I'm just, any number by itself is over 1, so most people don't know that.
Right.
So if you're multiplying it into the situation, students like seeing it that way because they can see the actual cross cancellation.
Yes, yeah, that's how I am.
Right. So just, however your style is, I always say over-explain because you never know what people don't know.
Right.
But you do one side, right?
Yeah, you gotta do the other side.
And then
Yeah.
come over here. You can put it over 1 again, but I would just, because there's no fraction over here, I just do that so they can see the cancellation.
Gotcha.
I just come over here and say, I did it. Okay. If you want to put it over 1 over there, fine. I mean, hey. And then you stop for a second. It's called check for understanding. Hey, who knows what crosses out here? So what do you think crosses out?
We just crossed out the delta and t.
Delta
per time.
T to say
Delta
it
T.
together. You made it separate,
Yeah.
delta T.
Delta t.
So
yeah.
you could,
So you just cross it like out, across, like just like.
You could, however you want to do it. Just make sure it's known and cross out. Students got to make sure it's struck out in their notes. You're going to strike out feature. Rewrite, right? What's your new equation? So you just flip this, because that's how mathematicians think, or scientists think.
Yep.
We read from this way to this way. We're human, like a typewriter. So
Yeah. So
You
then it would
rewrite
just be.
delta omega. You almost got me saying W. delta T.
Delta T.
And y'all be trying to get me to say regular human words. Find my alien physics words. Right? So that's our new equation. And then the last part, everybody loves, we celebrate this part, plug and play, right?
Yes.
Because kids don't like you playing without numbers. Just saying. Conceptually, they're supposed to. But that's how you solve problems. You don't work with the numbers until you have a working model.
Right.
So delta omega effectively is this, right?
Yeah, so we just plug in the numbers from there and then multiply it, right?
Right. Super simple. But you gotta make sure you cross things out and make it correct. That's all I was gonna say. So we have 3.48, right? That's rads per second. Put that in parentheses. I usually put parentheses so it stays together when they multiply and stuff.
Mm-hmm.
And then group it with this one. Our average acceleration is alpha AV is, well, I did it backwards. So it's delta T. I should have did this one first. But it doesn't matter, their product. So it's going to be 3.57 seconds, right?
Yes.
Now, you want to make a note to tell them what's happening here, right? This is supposed to be seconds squared, by the way. There we go. So what happens is, I don't know if you can see it, this seconds is in the numerator,
Yeah.
right?
Mm-hmm.
This seconds is in the denominator.
Right, so then
You
we're
put
gonna
them
have to cancel
together,
out,
you'll
right?
cancel out one of the seconds and make it official. That's how you check your
Gotcha,
math,
yeah.
dimensional analysis. That's what scientists are big on. So you want to make sure they check. This is also mastery for your professor,
Right.
that you understand what you're doing, especially if a scientist is looking at your work. If your dimensions don't match up, that's how buildings fall down.
Yeah.
Yeah, because you're using the wrong dimensions. So now, if you check, it's called checking your math. If you check your
Right,
math, I do this with the students all the time, make sure you get back to this.
Right.
Make
Because,
sure,
yeah.
because you can see how seconds will eliminate one of those seconds down there.
Right.
Because the second
And it
square is
goes
the
to-
bottom, that 1 second absorbs on
Yeah.
the top and leaves this with the seconds in the bottom. So now we can officially rewrite. Let's just do a quick calc.
Yep, I got the calculator.
And they be like, you be doing math, Tyler? No, I'm just, you be doing magic. I'm like, no, I'm just doing math, brother. 3.48. And you want to tell them, do not put the dimensions in there. Sometimes they put the dimensions in. It's like, you only do that for notation purposes.
Yeah.
So you get approximately 12.42, right?
Okay.
Come here and write that. So
I'm gonna do that right now.
delta omega is equal to, like we said, 12.42. And that's going to be, remember, our cancellation. So it should be rads per second. And that is all she wrote. Okay, now this is going to be a tough problem for kids because I think right there it's covered on Tuesday and Wednesday.
Yes.
So probably by Wednesday they should be semi-comfortable with it.
Okay. Gotcha.
Okay?
Whenever y'all, I know you staying because you got the field trip today.
No, I'm not. I told Rush I can't go. I got a Masonic meeting tonight.
Okay, well, whenever you all are done, you all.
Yeah, I'm just helping her prep for Wednesday.
Yeah. Thank you.
You're welcome.
Okay.
Yeah, that works. Yeah, so 12 point. So we just had to do 12.42. We don't have to add any more.
Well, I only go
after
2
that.
digits past what I need. I don't let them put all the rest of the numbers in there, right? If it's roundable, right? So that wasn't roundable. It's like 4, 2, 3. If it was like a 5 after that 2, I'd round it and just leave the rest of those numbers alone. And the kids know that too, right? For accuracy. All right. So that's all I got. And then all you gotta do is practice this. I'll try to, like I said tonight, download this off of Facebook and put it in YouTube form. Send you the video.
Okay.
And I strongly encourage you to, I don't know if you have an audience member or somebody at home to watch you do it.
Yeah.
And they just, make sure they're keeping up with you recording, but record yourself. That's how you be comfortable with it.
Okay.
Right? Not just doing it on paper and over and over. Record
right.
yourself
No,
doing it.
100%.
Review yourself. And,
How I saw
critique
it.
yourself
Yeah.
after you, like, am I loud enough? Or did I explain everything, right? And then you also got to time it, too, because I think you only got 20 minutes. So make sure, you let the professor know what part of the class you're going to take over. I'll even announce it. Like, okay, now Ms. Garcia, she's going to do, I'll even do it like that. She's going to do the we do for y'all.
Yeah. That'd be good too, because maybe that's what something I think maybe that's something with, for good practice I can do that and stuff like that. It's a nice lesson plan and everything else is there. I think that's everything that I need. So I'll go ahead.